Now, motion in two dimensions is just an extension of motion in one dimension. Before we get there, I just want to remind you about the motion graphs and quickly. Again, this is a review. First one, the position time graph. Time on the X, position on the Y, and what kind of graph is this? Or what kind of object is this graph representing, in fact? Now you see that the slope of this graph, as you go from the origin outwards, the slope is increasing, which means that the velocity is increasing because the slope of the position time graph gives velocity. That means this object has an increasing velocity. Maybe a constant acceleration, but definitely it has an acceleration. So, important point, the slope of a position time graph gives velocity. And, well, that's not true. So, let me just go down to the velocity time graph. In the velocity time graph, slope gives you acceleration. So, the slope gives you acceleration. The greater the slope, greater the acceleration. If the slope is negative, then that means it has a deceleration. Another important thing is that the area of the velocity time graph, you see the shaded part, that gives you the displacement. Very important. Area of the velocity time graph gives you displacement. And the third graph is the acceleration time graph. And in this graph, you can see that the object has a constant acceleration for a certain time. And if you find the area of that graph, you are going to get the change in velocity. Why? Because the area is given by AT, right? A multiplied by T, because it's a rectangle. And we know there is an equation that says that Vf minus V naught is AT, which means that AT is equal to the change in velocity. So those are some important things about motion graphs. Which brings us to motion in two dimensions. Now remember that in this type of a motion, the object is moving both along the x-axis and the y-axis. And the important thing is to remember that the horizontal velocity of the object is not affected by gravity. So, which means if you have a projectile, initially it has both horizontal velocity and vertical velocity, and it's only the vertical velocity that's affected by gravity. So the vertical velocity changes. It first decreases. At the highest point, the vertical velocity becomes 0, and then it increases. But throughout the motion, the horizontal component stays the same. So that is what is shown in this diagram. So you see that it has two components. The velocity does. But if you watch, you see that the length of the horizontal component is always the same. It does not change. But look at the vertical component. It first decreases. At the highest point, the vertical component becomes 0, and then it increases in the opposite direction. So that is what you have to know about motion in two dimensions, and this is a typical example. So at the highest point, does the object have any velocity? Yes, it does. It has its horizontal velocity. What about its vertical velocity at that point? It becomes 0. Now, we can treat these two components separately to find three quantities. Number one, we can find the time that it takes to go from the point of projection to the landing point. We can find the horizontal displacement, and we can also find the maximum height. So the time, the horizontal displacement, and the maximum height. Okay, that's just me writing down the important stuff, and maybe you just, this is a very important point. V naught cosine theta naught, because the angle is given as theta naught, is the horizontal, and V naught sine theta naught is the vertical. Obviously, V naught is the initial velocity. Which of the components is constant? The horizontal, which is V naught cosine theta. And V naught sine theta is affected by gravity. So let's find the time of flight, because it's actually flying from A to B. So to find the time of flight and the maximum height, both of these cases, we only use the vertical initial component, which is V naught sine theta. Therefore, V naught is V naught sine theta. Now, don't be confused with that. This is just the symbol of initial velocity, which in this case is V naught sine theta. And what is delta y as it goes from A to B? Delta y is 0. It doesn't go anywhere vertically. And A is negative g, t is what we are trying to find. So the equation that has all four of these is this one. V naught t plus half at squared. So plug it into that equation. Rearrange that equation, and then you get the formula for time of flight. That is just a few mathematical steps there. It's just rearranging and all that. Of course, you have t squared and t. One of the t's gets cancelled here. And then when you rearrange, you get 2 V naught sine theta by g. So this way you can find the time it takes for a ballistic missile or any projectile, for a javelin or whatever, using this formula. You just need the initial velocity and the angle of projection. Now, to find the maximum height, we should remember that the vertical component at the maximum height is 0. The vertical component at the maximum height is 0. So the initial is V naught sine theta, A is negative g. We're trying to find the maximum height. So use this equation and you get, well, I forgot to list that the final velocity is 0. So the final velocity at the highest point is 0. So I wrote that down now. And then you get 0 is equal to V naught squared. Just plug it into that, rearrange. And you get delta y. The m there stands for maximum. So maximum height is V naught squared sine squared theta by 2g. Okay, now how do you find the horizontal displacement? For that, you use the horizontal component of the velocity, which we know is a constant. And if the velocity is a constant, you just have to multiply it with the time for which it remains a constant. And so that's easy. Therefore, you multiply V naught cosine theta, which I'm going to do in a second, because V naught cos theta is a constant. So we use this equation. Just multiply that with the time, which is the time of flight. And we've already got the equation for time of flight, which is 2 V naught sine theta by g. And actually here you can see V naught squared, 2 sine theta cos theta. See, 2 sine theta cos theta is an identity which can be written as sine 2 theta. So that becomes sine 2 theta by g. Why? Because 2 sine theta cos theta is nothing but sine 2 theta. So if the angle of projection is given as 30 degrees, you're going to take sine of 60 degrees, which is 2 times 30. So that's how you find out the time of flight, the maximum height, and the horizontal distance. Finally, another example for two-dimensional motion is the motion, let's say, of a speedboat or a boat in a flowing river. Well, in a river, because a river obviously flows. Okay. So let's say that the width of the river is delta y, and the water is flowing at a velocity vx, and the speedboat just want to go across, just wants to go from one point exactly to the opposite point. So let's say that it starts from here. If it starts from here, we know that it's never going to end up here, okay, because the water is flowing down. So it's going to be, the resultant velocity is going to be the vector sum of Vx and Vy. So that means if it starts from here, the speedboat is going to end up here. There are some interesting calculations here, which I'm going to show you in a minute. So that's the boat starts from A, wants to go straight across, but ends up at B. So now, can you find the time it takes for it to go across? Yes, you can. I'm just going to say that horizontal and vertical motions are completely independent of each other. And since we know that in this case the velocities are constant, both the velocities are constant, we will just use the equation for displacement being equal to the product of velocity and time. That'll be very interesting. So the time to go from A to B, let's call it delta t. That's the case, delta x is equal to, well, that's delta x is going to be Vx times delta t. And delta y is going to be Vy times delta t. That's it. And also tan theta, to find the angle, is opposite side by adjacent side, which is delta y by delta x, which is Vy by Vx. That's pretty interesting. So using that, you can find out how much it has moved horizontally and the width of the river. So those are some key points, and remember that this has been a review, and that's why I've been trying to speak fast, and I hope you like this. Go ahead and spread the news. Physics is what I enjoy, and I want more people to really get hold of this subject that people say are it's really tough. It's not. It's just that you got to understand. And please subscribe to my channel, which I'm writing down now, which is, of course, www.youtube.com/Oman. Take care of the spelling of Oman, Oman, or you can just Google for Oman George and you will get it. Thank you so much. It's been a pleasure teaching you physics. I hope you continue to enjoy physics and do good in your life, becoming engineers or whatever makes you apply physics in real life. And I'm passionate about this, and I want you to be passionate about this, and I hope it helps you. Send me your comments. Thank you for listening in. Have a great day.